water.
Yeah, let's go.
Hey Angelica, there's no water in the faucets.
What do you mean there's no water in the faucet?
There's no water. Maybe it's just this thing. We can go check the drinking fountain.
Yeah, let's go.
Angelica, there's still no water in the fountains.
We got a problem.
Let's go tell Kamini about this.
Yeah, let's go. Kamini! Kamini, there's no water!
What? What's happening? What?
There's no water in the faucets.
What faucets?
In the science lab.
What's going on here? This is so strange because I've been out here all day trying to measure how deep the water is in these boreholes. And you know what's crazy is I can't find it. I've been using this tape that should beep when it hits the water. So, for instance, if there had been water in my well, I would have heard that noise. But I've been to tens of these wells this morning and I haven't found water in any one of them.
But why is water so important?
Well, water is really important for drinking, but groundwater in particular is important because almost half of the water that we use for drinking comes from groundwater. And there's 20 times more water in the ground beneath our feet than there is in the lakes and streams that we see on the surface. So if there's no groundwater, we've got a real problem. I wonder if we should go find Holly Barnard at CU and ask her if she knows anything about this.
Yeah, let's go.
Let's go.
You call that transpiration? I need more! More!
Hi,
guys.
Holly. We were outside with Kamini and we just noticed that there's no water in the ground, the wells, the faucets, or the drinking fountains. So we thought we'd come ask you about it.
No water? That sounds like a big problem. For lots of reasons. Come on in. So, tell me about this water problem you're having.
So, we went into the science lab to get a drink of water and we turned on the faucets but no water came out.
Well, the city probably just turned the water off.
Well, we also went to Kamini, but she couldn't find any water in the wells either.
Kamini Singha?
Yeah.
She's a very famous groundwater hydrologist. Wow, what is it? And she didn't find any water in the ground?
No.
This sounds like serious business.
Yeah, we also saw this crazy woman.
A crazy woman?
Yeah.
What was so crazy?
She was throwing pine cones at the trees.
Pine cones? You know, I think you probably should just talk to Kamini about this. I have a meeting I need to go to, and just let yourselves out when you're
Really
done.
weird.
It was.
Hey, Holly forgot her boots. Why would she go to a meeting without shoes on?
Those same red boots were on the crazy lady.
That's really weird.
And I was looking around and I saw this pine cone.
She was throwing pine cones at the trees. Maybe the crazy lady was Holly.
Maybe it is.
We should call Kamini about this.
Hello?
Hey Kamini, it's Selena and Angelica.
Hi guys, what's going on?
We came to talk to Holly about the water problems we were having and it was pretty strange.
What do you mean she was acting weird?
She walked out of her office really fast and when she left we found the red boots that were on the crazy lady outside.
Well, that's a pretty serious accusation to make about a scientist. Maybe we should make sure that this is true. Why don't we come up with a plan to try to bring her out? Let's meet on the side of the Instar building here in an hour. Would that work for you guys?
Oh, that sounds like a great idea.
Next soon, but for now, here's some clips from our interview with Holly Barnard and Kamini Singha at the Instar building.
I'm Holly Barnard at the University of Colorado.
And I'm Kamini Singha at the Colorado School of Mines.
I research forest hydrology, or sometimes called ecohydrology. So I'm interested on how plants influence the water cycle.
And I study groundwater hydrology, so I think about the other piece of the water cycle that's beneath our feet. And I also use methods that are sort of like x-rays to look at what's happening in the subsurface, in the ground beneath us, in terms of how water moves and what's in it.
What was most challenging about the subject?
I think one of the biggest challenges for me, at least going through my education, is that I chose a very interdisciplinary topic, which means I'm not focused on one thing in particular. So I had to learn about trees and how they work, and then I had to learn about hydrology and then how that works, and then also had to pick up a little bit of geochemistry or water chemistry. So it took an ability to be really adaptable to lots of different subjects.
I think that's a good answer to that question for science in general these days, which is that a lot of the really interesting questions that we're asking about the Earth system, at least, have all these intersecting fields that we're thinking about, biology and chemistry and physics and mathematics. And so figuring out how to get all those pieces together to answer really interesting questions, I think is maybe one of the greatest challenges that we have in Earth system science right now. So I think my answer would be really similar, which is that trying to figure out how to take little pieces from all these other fields and all the things you learn when you're in school and put them together to answer a bigger question, I think is the hard part.
That's all the time we have today. Now back to our movie.
How about this one? Let's cut down this tree. Wait! Stop! What are you doing? Have you ever heard of global warming? What difference is global warming mean if we don't even have water to drink? Water comes from our faucet. Water does not come from our faucets. Water comes from the ground and from surface water. And if your trees are drinking all of it, then there's nothing for us as humans to drink. We need the trees to drink the water so they can photosynthesize to get the carbon out of the atmosphere and reduce global warming. Trees are helping us. Well, then what are we supposed to do about this water issue? Like, can you cut down some of your trees? You can't cut down any trees. You're supposed to be planting trees. Can we drink less water? We could work together on that. We could.
Later.
Sorry.
Okay, so how did this all start?
I started by water not coming out from the faucet, and then we went to find Kamini.
Yeah, and when they found me, it turned out that I was measuring water levels, or trying to, in the wells, and there was no water to be found in any of the wells that we had. And so it got us asking some questions about where the water was going. And we found out that Holly, we thought, was stealing the water with her trees.
Yeah, and I needed my trees to use water because trees need water to photosynthesize. So to fix carbon from the atmosphere, trees need water to turn that into sugar. So that helps with our climate change problem. But I didn't realize that when the soil's really dry, that sometimes the trees have to use groundwater.
And I didn't know that trees were an important part of climate change. All I knew is that the drinking water that we use, that we take out of the faucet, almost half of that comes from groundwater. So I thought maybe Holly was up to no good.
I'm just glad we resolved everything.
Me too.
Me too.
I'm glad we resolved everything too.
Here's to water.
Cheers.
Cheers.